that will represent this 0 to 9. So similarly, what will be for 1? We need to add with this. Okay. So what will be the result?
0100.
0 1 0 0. Okay. Similarly, suppose for 7. 7 is what? 0 triple 1. Here I need to add 0011. So what will be the result?
1010.
1010. Okay. So you can see this 0 in excess 3, 0011. 9. 9 will be 9 plus 3, which will be 12. So it is 1100. So you can verify all of this. So now these combinations will represent from 0 to 9. These combinations will represent from 0 to 9. So this is another BCD code. This is another BCD code where we are able to write from 0 to 9 by adding 3 to 8421. Okay. So the question is now, what do you think? How many codes will be illegal here? How many codes will be illegal?
0 to 9.
No, why 0 to 9? First of all, how many codes means how many combinations will be illegal? Anyway, you are
9.
representing. No. Anyone else? Anyhow, this is BCD code only. What is the logic behind BCD code? We are representing from 0 to 9. Means how many numbers? 10 numbers. We are representing them with 4 bits. So how many combinations
Yes, sir.
possible? 16. So whatever the BCD code, always 6 codes will be invalid. 6 codes will be invalid. So only difference is here other 6 will invalid, here other 6 will invalid because codes are different. But anyhow, whatever will be the BCD code will represent 10 only. We will use only the 10 combinations. So 6 combinations will gonna be unused. So what will be unused codes in this XS3? कौन सा कोड होगा जो कि इलीगल होगा, which are unused?
So 0000.
Then
0001.
yes, great. Then
0010.
yes, great. Next
1101.
1011. No, thoda
1101.
again repeat that one. I didn't hear you.
1101.
1101.
1101. Great. So basically, what is happening? We are representing from 0 to 9. So basically, क्या होगा? Add कर रहे हैं 3. So 0 plus 3 should be 3. 1 plus 3 should be 4. 2 plus 3 should be 5. 9 plus 3 should be 12. So basically, what we are representing? 3 to 12. So what are unused? So just compare with this only, huh? Normal binary. So if we compare, which codes are unused? 0, 1, 2, 13, 14, 15. 15. Okay. So 0 means what? 40. 1 means what? 0001. 2 means 0010. 13 means this one. 14 means this one. 15 means this one. So these 6 are unused. These 6 are unused in this XS3 code. Okay. So it has certain significance. So that's why it is XS3. Why not XS4? Why not XS5? Okay, we'll see this later on. So what is the significance of this code? When we'll go for classification, we will see. Okay, so it can be anything. Now we can go for XS4 also, XS5 also. Then why particularly this is used? This combination is used. Okay, so this is one kind of code, XS3. So any doubt in this XS3 code? Anyone in doubt? Yes or no?
No, sir.
Okay.
No, sir.
So next kind of code is gray code. So gray code is not a BCD code. First point is it is not a BCD code. So we can represent any number with the help of this. So it is just it will be different from the binary. It will be different from the binary numbers. So what will happen here? So why this comes into the picture? So first of all, tell me Suppose I want to represent 0 with the help of 4 bits binary number. So what will happen? 0 will be equal to 40. So in decimal number after 0, what you are getting? In decimal number after 0, what you used to get? 0 के बाद 1 आता है. Great. In binary number, if you represent it, it will be 0001. Now, after 1, what you are getting in decimal number? You are getting 2. What is the equivalent of 2 in binary? 2 is 0010. Next, 3. उसके बाद क्या आता है? What is to get? 3. 3 is 0011. Next, 4. After 3, we are getting 4. Its equivalent is 0100. Similarly, 5. It will be 5 0101. 6 0110. 7 0111. 8 क्या होगा?
1000.
1000. Let us stop here. It can exceed. Let us stop it to this to analyze. Now, here what you see that after 0 I am getting 1. After 1 I wrote 2. After 2 I wrote 1. I add 1 means 3. After 3 4. After 4 5. After 5 6. After 6 7. After 7 8. So sequentially I am going from 0 to 8. Okay. Now in binary, if you will see, okay, what is happening? So basically the binary number is what? This is a combination of zeros and 1. So here if I will see how many bits are changing. So here it is represented with 40. Here represented with 0001. So how many bits change here? Or in how many position your bits were changed?
1.
Here this position got changed. Okay. Now from 1 next we got 2. It is sequential. After 1 I am getting next is 2. At the same time, if I'll see to this binary number, how many bits were changed? 2. This is changed. This is changed. This 0 is changed to 1. This 1 is changed to 0. Okay. Now let me proceed to. I will not check for all combination. Now let us concentrate on 3 to 4. When I am going from 3 to 4, how many bits are changing?
3.
This is changing. This is changing. This is changing. Similarly, when I am going from 7 to 8, how many bits are changing?
4.
4. All are changing. Okay. Now, basically, what happens in this digital, this is nothing but a circuit. If in a circuit, if this bits changes, suppose 0 change to 1 or 1 change to 0. So what happened? Unnecessary power is getting wasted. Okay. To make that happen, you are utilizing the power. So what is happening? Your power is unnecessarily getting wasted. So more changes means more is the wastage. More power will be getting wasted. Okay. We are here going in a sequential manner from 0 to 8. Suppose 0, next I am getting 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. But at the same time, it corresponding binary code, what is happening? It is not changing by 1 bit. It is changing by maybe more than 1. It can be in 2 bit, 3 bit, 4 bit. We see here that this changes by 1. Here it changes by 2. Here it changes by 3. Here it is changing by 4. So unnecessarily your power is getting wasted. To solve that issue, gray codes are used. So its concept is for each succeeding digit, only one bit should change. It shouldn't change by more than in one position. So at max only one position, only one bit can change. So that is the requirement. So what will happen? So it is possible. We need to follow certain steps to do that. Okay. So what to do? The same thing is mentioned. When you count up or down in binary, the number of bit that changes with each digit changes varies. From 0 to 1, only single bit. 1 to 2, 2 bit changes. 7 to 8, 3 bits. Okay. So depending upon number of bit, it changes. Now, how to convert? First of all, if a binary number is given, how to change it to gray code? Okay. So what will tell me any 4-bit number? Any 4-bit number? Any 4-bit example? Your choice.
One
Anyone?
one zero one.
1101. Then how to convert this into a gray code? Okay. So what we'll do here? What is the name of this bit?
Most significant bit.
Most significant bit. So whatever is mentioned here, you simply write it, copy it. Okay, so this is the binary code. I'm finding the gray code. So whatever is written, I just copied it. So everyone, do you know about XOR gates? Is it
Yes, sir.
everyone know?
Yes, sir.
Everyone
Yes,
Yes,
sir.
sir.
or anyone do not know about XOR? Anyone do not know about XOR? Anyone not studied? Because XOR will study in the next part once this chapter is getting over. So we'll require here, otherwise I will explain in different way. Anyone do not know about XOR? Okay, that means everyone knows that. So what do you mean by XOR? A XOR B. A XOR B is what? This is A bar B plus A dot B bar. So what do you mean by this XOR gate? XOR performs what? It performs the logical operation. So what is the definition of XOR gate? Can anyone tell? Can anyone tell about definition of XOR gate? Means what used to get in XOR? If XOR is having two input, what happens to output?
One of them is true and one of them
If
is
both
not.
the inputs are same, then it will give one. Or if they have different input, then it will give zero.
ने उल्टा बोल दिए ठीक है दैट इज इन XNOR
दोनों में से किसी में अगर वन रहेगा तो वन आंसर देगा दोनों
Okay.
सेम रहेगा तो जीरो
okay let us write here so from that we'll able to write tell suppose A
आप एक बार एक्सप्लेन कर ही दीजिए सर
A XOR B so AB is 0 0 0 1 1 0 1 okay so what will happen here you can apply this formula what result you will get here in A XOR B A bar B plus AB bar
जीरो
this will be 0 1 1 होगा तो
जीरो
apply 0 this is 1 okay so from this we can understand that A XOR B is what if two inputs are same if two inputs are same then it gives output to be 0 if two inputs are different then this output is 1 okay so exactly we're gonna follow this method here okay so what to do we'll perform this XOR operation here so first what happens when we converted binary into gate whatever is your most significant bit I copied it then what we'll do basically horizontally I will do this XOR operation so this two bits 1 1 it's XOR what will be the result XOR of 1 1 will be how much you can see this table and answer XOR क्या होगा 1 1 का
जीरो
0
Zero.
next what we'll do we'll perform XOR of this two so it is 1 0 1 0 का क्या होगा
One.
1 then we'll perform XOR of this two 0 1 so what will be XOR of 0 1 1
One.
okay so what happens 1 1 0 1's gray code is 1 0 1 1 okay so this is just mathematical formula is written if it is n bit how to convert so basically first of all we need to copy most significant bit then horizontally you need to do the XOR operation okay so quickly you do it for 0 to 15 what will be the gray code do it for 0 to 15
सर
हम्म,
जैसे बाइनरी कोड का बेस हमारा 2 होता है, ग्रे कोड का भी कोई बेस होता है?
Gray code is also 2. Gray code is also a binary code only. We are using only 2 bits only, 0 and 1. Verify all this.
Yes, sir.
ठीक है, सब कुछ ठीक है?
Yes, sir.
So any particular example you want to perform? Anyone? कोई particular example from 0 to 15?
No, sir.
No, sir.
Okay. So in this way we can convert binary into gray code. Okay. Next. It's reverse. It's opposite. Okay. Now suppose the gray code is given and we want to find out the binary. Then what to do? Okay. Now suppose tell any exact took any one of gray code. We'll convert that into binary. You wish
0100.
0100. That means this one. Okay. So what to do? First, can you comment about its most significant bit? What will be its most significant bit? क्या होना चाहिए?
0.
Previously also we did the same thing. Whatever is the most significant bit, it needs to be copied. So we copied it here. Previously, what we did, we took XOR operation in horizontally. Now, only difference is this will happen diagonally. Okay, so this next will be XOR of 0 1. So, what will be the result of 0 1? XOR of 0 1 1.
1.
Then XOR of this two, what will happen? 1 0. XOR of this will be
1.
1. Again, XOR of this 1 0.
1.
This will be 1. So, this result is 0 triple 1. Take another example. Any other combination?
1110.
Triple 1 0. So what to do? First we'll copy most significant bit, 1 copied. Then XOR of this two, 1 1 0. Then XOR of this two, 0 1. Both are different. So 1. Then XOR of 1 0. Both are different. 1. So triple 1 0. This its corresponding will be 1 0 1 1. Okay. In this way, you can convert binary into gray or gray into binary. Okay.
Yes.
So same thing is mentioned here.
सर एक बार फिर से एक्सप्लेन करिएगा वो बाइनरी ग्रे वाला.
बताओ, कोई भी बताओ एग्जांपल यहाँ से बताओ देख के, कोई भी एक्सप्लेन चाहिए.
सर जैसे 0010.
0 0 1 0. So this is in binary or gray? What do you want?
Sir, it is in gray converted into binary.
Okay, it is in gray. We want to convert this into binary. That means this one. So what to do? First of all, we need to copy this most significant bit. So it is copied. Okay. Then what to do? We need to do this XOR operation diagonally. So 0 0 both are different. So output will be what? Sorry, 0 0 both are same. So output will be 0. Then diagonally again I will do 0 1. Both are different. So output will be 1. Then again diagonally XOR operation 1 0. Both are different. So output will be 1. So this is 0 0 1 1. Okay. So just remember, when we are going from gray to binary, we are doing XOR operation diagonally. When we are going from binary to gray, we are taking XOR operation horizontally. That is the difference. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Yes. So it binary, ये तो ग्रे टू बाइनरी था ना. कोई भी एक एग्जांपल बताओ आउट ऑफ दिस. 1 1 0 0. So what will happen? First of all, we copy this most significant bit. Okay. Then what we'll do? We'll do this XOR operation horizontally. So 1 1 both are same. क्या हो जाएगा XOR? 0. Then XOR of 1 0 both are different. So output is 1. Then 0 0 both are same. Output is 0. So 1 1 0 0 का 1 1 0 0. This क्या हो गया? 1 0 1 0. को 1 1, अच्छा बाइनरी था ना, गलत कर दिया यहाँ पे. 1 1 0 0 कहाँ है? This one. 1 1 0 0. So its one is 1 0 1 0. ठीक है. So binary horizontally, where if you are converting gray into binary, you have to take diagonally XOR operation. So next is classification of different. Yes.
तो ग्रे को डेसिमल में भी पॉसिबल है कि नहीं? मतलब क्या आते हैं वो पॉइंट के बाद, जैसे 100.0 समथिंग.
No, this is only for this numbers.
ओके सर.
So next is classification of codes. So there are different codes are there. So how to classify them? Okay. So there are different classification. Okay. One is weighted code, non-weighted code. This can be called as a reflective code, sequential code, alphanumeric code, error detecting and correcting code. So different ways are there in which we can classify. So we'll learn about one by one. So again, short questions are possible out of this definition and the reason. So first is weighted code. Okay. So a code will be called as a weighted code if in each position certain weights are assigned to it. If corresponding to a position will assign certain weight, this will be called as a weighted code. If no weights are assigned, it will be called as a non-weighted code. Okay. So example of weighted, whatever we discussed. Can you give an example which code is a weighted code where we assign certain codes? किसमें हमने असाइन किया था वेट? कौन से कोड में? किसमें किया था? इसमें किया था ना 8421 में. We assigned codes na weight to each position 8421.
Yes, sir.
This code is a weighted code. This code is a weighted code. Okay. Now question is, now suppose think about this. This XS3, is it a weighted code? Is there any particular weights are assigned to each position? Is there any weights are assigned to each position?
No, sir.
How we are getting? We are first finding 8421, then we are adding 3. So there is no specific weights are assigned to each position. So XS3 is a non-weighted code. Next, what about this gray code? This is weighted or non-weighted?
Non-weighted.
This is also not
Non-weighted.
We are not assigning any weights to this. How we are getting? We are doing this XOR operation and we are getting this. So this is also non-weighted. Okay. So example of this is 8421. So there are also different codes are also there like 2421, 84 -2 -1. So as you can see, code this position is having certain weights. Accordingly, this is defined. Non-weighted means this XS3 code and this gray code. Okay. Next is sequential code. So in sequential code, what will happen? Each succeeding code is one binary number greater than the previous code. Sorry. So what will happen in sequential code when we are going from 0 to 1 and 2? So basically what is happening? 0 plus 1 is 1. 1 plus 1 is 2. So this is in sequential. Now think about 8421. What is happening here? 0 is 40. What is 1? 1 is 0001. So if you add 1 to this, you will get this 0001. Similarly, if you add 1 to this, what will happen? You will get 0010, which is the code for 2. Similarly, what is 3? If you add 1 to this will be 0011, which is the code for 3. So if this is the case, then code is called as a sequential code. So in sequential code, each succeeding code means this is one binary number greater than the previous one. One binary number greater than the previous one. So example is 8421. Okay. So XS3, is it a sequential code? Will it happen in XS3 also?
Yes, sir.
XS3 also same thing. 0 is what? 0 is 0011. 1 is what? 0100. So if you add 1 with it, you will get 0100. And also it has to be satisfied with all the combination. Okay. So exactly same thing is happening here. So this 8421 code and XS3 code is a sequential code. What about gray code? Gray code is sequential or not? Check this.
No, sir.
Here if I'll add 1, I will not get 0011. So it is not a sequential code. Okay. Next, cyclic code. In cyclic code, what happens? Each successive code differs from the preceding one only in 1 bit position. So two consecutive codes, if it differs only in 1 bit position, it is called as a cyclic code. So what is the example of this? In which code only in one bit it changes for the succeeding code?
Great.
Gray code. Here only gray code only it is changing by one bit position. It is not happening in other codes. So gray code is cyclic, other codes are not cyclic. Okay. Next is reflective code. To understand the reflective code, let me directly go to the next slide. So here you can understand. So here you can see I represented the gray code. Okay. 1 bit, 2 bit, 3 bit, 4 bit. Now concentrate on this. Start with this 4 bit. Okay. What is the name of this bit? First bit. What is the name of the first bit?
Most significant.
Most significant bit. So what I am doing, I am just removing it. Okay. So in 4 bit, I removed the most significant bit. Okay. Then how many remaining bits are there after removing this most significant bit? पहले 4 bit था, I removed 1 bit. So how many is remaining?
3.
3 bit. Okay. Now, if you have 4 bits, how many combinations are possible? How many combinations are possible? 16.
2 क्या 4. Yes.
If I divide by 2, how much it will get? You will get 8.
8.
Okay. So what I am doing, then I am dividing these combinations by 2. So I am separating the 8 ones, first 8 ones and later on 8 ones. Okay. Now you see, what is this? 100. What is this? 100. Here 101. Here also 101. 111, 111. 110, 110. 010, 010. 011, 011. 001, 001. 000, 000. Okay. So what happens? It is 4 bit. Most significant bit is removed. So remaining bits, what is happening? These are the reflection of this. So these combinations, these numbers are same. So exactly same thing happens for this 3 bit also. 3 bit है तो कितना combination होगा? 8 combination. So
Yes.
we need to divide by 2. So 4. 3 में अगर most significant bit हटा देंगे तो it will remain 2 bits. So this is half. Then you can see 10, 10, 11, 11, 11, 01, 01, 00, 00. So exactly this thing happens here. This will not happen in other codes. You can see here this property you will not get here. Okay, they are different. So the definition of reflective code is it is mentioned in which reflective code is a code in which n least significant bit. That means by removing the most significant bit, whatever is remaining, for code words 2 to the power n through 2 to the power n plus 1 minus 1 are mirror image of 0 to 2 to the power n minus 1. So whose example is gray code. Whose example is gray code. Other codes are not this reflective code. Only gray code is reflective. Next, self-complementing code. Okay. So now tell me any number between 0 to 9. Any one number?
7.
7. Okay. Like we are calculating one's complement. How we used to calculate one's complement? One's complement कैसे निकाल रहे थे उस टाइम में?
Interchange कर देते थे. 1 को 0, 0
No,
को 1.
that is the shortcut. What was the actual method? That was a shortcut.
Subtracted from 1, 1, 1, 1.
We subtracted. If it is 4 bit, basically we are subtracting with 1. Okay. Similarly, its counterpart in decimal number will be 9's complement. 1's complement, 2's complement's counterpart will be 9's complement and 10's complement. So what will happen if number is 7? What will be 9's complement of 7? कितना होना चाहिए? 9 minus 7 कितना होगा?
2.
2. Okay. Now, suppose take a example of BCD code, natural BCD 8421. So 7. How we are presenting with 7?
0 triple 1.
0 triple 1. 2 2 को कैसे करेंगे? 0 0 1 0. Okay. So a code is called to be self-complementing. A code is said to be self-complementing if we can get this code, if we can get this code by interchanging zeros with 1 and ones with 0. Here, if we'll interchange zeros with 1 and ones with 0, क्या आएगा? 1 triple 0. But that is not the case for this. Okay, so 8421 is not a self-complementing code. Now let us see XS3. What is happening in XS3? 7 क्या होगा? 7 का XS3 code क्या होगा? 7 plus 3 10. So how much will be 7? 7 का XS3
1010.
1010. 2 का XS3 2 plus 3 5 कितना होगा?
1 0 1.
नहीं 5 है.
0 1 0.
0 1 0. Now you interchange this. This is interchanged, and it will be applicable for all the combination. Okay. So if you can get, so definition of self complement is if code word of 9's complement of n can be obtained from the code word of n by interchanging all the zeros and 1. If by interchanging these codes of number n, if you can interchange and you can get the 9's complements code word for this, then the code is said to be a self-complementing. So example will be XS3. 8421 or gray code will not be self-complementing. Okay. So remember the short questions are possible with reason. Why suppose a self-complementing? Why XS3 is self-complementing? Why gray code is not self-complementing? So like that questions can come. So next is classification is numeric code and alphanumeric code. So numeric code means the code with which we can represent only the numeric information, means numeric numbers 0, 1, 2. We can represent the numbers only, then that code is said to be a numeric code. Example 8421, XS3, etc. Here we can represent the numeric information. Next code is alphanumeric. As name suggests, alphanumeric means we can represent both alphabetic and the numbers. If we can represent both, then it is called as a alphanumeric code. Alphanumeric code. Its example is ASCII and EBCDIC. Okay. So just remember these names. Detail is not required. Okay. So numeric code, we can represent the numbers. Alphanumeric, we can represent the character and also the numbers. The next important one is error detection and error correcting code. This is very, very important. Error detection and error correcting code. Now what happens? Suppose I am sitting here in place A. You all are sitting in different places in place B. Okay. Now suppose from my end I send data 1010. I am sending data 1010. Now you received some data here. Okay. You received some data in at your end. Okay. So you received this correctly or not correctly. You want to find out. Okay. Like I am speaking here. Now suppose network problem is there, you are unable to listen or unable to hear. That means what? You want to find out whatever I communicated, the same thing you received or not. Same thing you received or not. Okay. So depending on that also, codes can be classified. You can classify this as error detecting code, error, detecting codes, and error correcting codes. Okay. So in error detecting codes, what you can do, whatever you receive here, you can you can say that this combination contains error or no error. But where error is there, you'll not be able to find out. If you don't know in which place error is there, then we cannot rectify this. Okay. So that kind of codes are called as error detecting codes. That means you find out that there is a error, but where error is there, you are unable to find out. Okay. That code will be called as error detecting codes. Now, if particularly you can find out error is there in the first position or second position or third or fourth position, if you can find out in which position it is there, then you can rectify it. Then that code is called as error correcting codes. Error correcting codes. So basically you are detecting also and you are correcting also. So in detection, only you are able to detect. When you are correcting, both you are detecting and you are able to correct it. Okay. So let us stop here. We just understood its basic. Okay. So we're not able to finish
Okay,
it.
sir.
So next class we will do that. One second, don't leave the meeting. Let me take the attendance.